Hello and welcome to the Vodcast about the energy flow through ecosystems. Okay, here is the mind map for energy flow through ecosystems if you would like to take a snapshot. Otherwise, we're going to zoom in. First of all, we're going to talk about the importance of the sun. The sun is the original source of all energy in ecosystems. Light from the sun contains energy. The energy is captured by plants using their leaves. The leaves contain the pigment chlorophyll. Chlorophyll is used for photosynthesis. Photosynthesis uses water and carbon dioxide to make glucose. Therefore, plants turn light energy into chemical energy. Animals that eat the plants gain this energy. Without plants, there would be no animals on Earth. Next, we'll talk about the importance of plants. Plants use the light energy to make glucose. The equation for photosynthesis is 6 carbon dioxides plus 6 waters gives us glucose plus 6 oxygens. Plants are autotrophs in that they make their own food. Plants use their food for cellular respiration. The equation for cellular respiration is glucose plus 6 oxygens gives us 6 carbon dioxides and 6 waters. Plants use 90% of the glucose that they make for cellular respiration. Cellular respiration makes ATP, which is cellular energy, and heat. Plants store the other 10% for growth and reproduction. Next, we'll talk about food chains. A food chain is a simple feeding relationship. All food chains begin with an autotroph, which is a plant. An animal consumes the plant for food. An arrow shows the flow of energy to the consumer. So after the animal has eaten the plant, this animal in turn is eaten by another animal, then this animal by another animal, and then this animal by another animal. Each time, an arrow indicates the flow of energy to the consumer. Each time, the organism uses 90% of the food for cellular respiration and only stores 10% for growth. Here we've got a 3-membered food chain. The corn is eaten by the rat and is eaten by the owl. Each time the arrow represents the flow of energy, and each time the consumer will use 90% of that energy for cellular respiration for itself. So each time only 10% of energy is passed on up the food chain. Here we've got a diagram that shows the relationship between photosynthesis and cellular respiration. In photosynthesis, there's an input of energy in solar energy, and in cellular respiration, there's an output of energy as ATP and heat. Energy is not recycled in food chains and food webs. It comes in and leaves. Next, we're going to talk about the vocabulary. An autotroph makes its own food. The word autotroph means self-feeding. A producer produces glucose, so plants are both autotrophs and producers. A heterotroph eats another organism for food. A consumer consumes another organism for food. Therefore, heterotrophs are consumers. Trophic levels are feeding levels. Plants are trophic level 1 because they feed themselves. A consumer level is always 1 less than the trophic level. So a herbivore eats plants. It's trophic level 2, but only consumer level 1. A carnivore eats other animals for food. An omnivore eats both plants and animals for food. An apex predator is a top-level consumer. Next, we'll discuss the flow of energy in a food chain. Plants turn light energy into chemical energy. Plants use 90% of this energy in cellular respiration, and only 10% is passed on when eaten. A herbivore uses 90% of the energy is gained in cellular respiration and only passes on 10% when eaten. A carnivore uses 90% of the energy it gained from eating the herbivore and only passes on 10% when it is eaten. Trophic level 4, or consumer level 3, uses 90% of the food that it has eaten for cellular respiration and only passes on 10% when it is eaten. Same with trophic level 5. Then we've got an apex predator, which in this case is trophic level 6, and it will use 90% of the energy it has eaten in cellular respiration and therefore only has available 10% to grow. There is a maximum of 5 to 6 trophic levels for any food chain, as only a very small percentage of the energy makes it this far. Last of all, we have food webs. A food web is a series of interconnected food chains. Several autotrophs are at the base. Heterotrophs can be many trophic levels depending upon what food chain is being considered, but still there is a maximum of 6 trophic levels for any food chain. And there will only ever be a few apex predators. Decomposers such as fungi and bacteria sit alongside the food web. Decomposers are saprophytes. They eat dead organic matter. Saprophytes turn organic matter into inorganic matter. And it is this inorganic matter that is taken up by plants to be recycled. Thank you for paying attention. I hope you enjoyed it, and I hope it has helped you. Don't forget to like and subscribe, and I'll catch you later. Goodbye.